But if you look, section 1-2 is all about undefined terms and definitions. So the first thing they talk about here is to study geometry, you have to understand certain basic terms. Definitions are really important, and it's important that they are good definitions. So the first thing they do is give you a description of what is a good definition. First thing is obvious, it has to be accurate. If you give me a definition that is not accurate, you're not helping me at all. All right? The definition states the term being defined and clearly communicates the concept, avoiding ambiguous language. Ambiguous is like opinionated language, all right? Opinionated is ambiguous in a description. Understandable. The definition usually uses only words that have been previously defined or are clearly understood without being defined. So in geometry, they're not going to give you a definition using a geometry term that they have not already defined for you. Now, what this means is these terms are building. So there are going to be terms that we use in this chapter that you're going to use all year, and they're not going to redefine them for you. They're going to assume you learn the definition in this chapter. All right, but they are understandable. Reversible. What does this mean, reversible? The definition identifies the class to which the object belongs and its distinguishing characteristics. So if I said, and they give it down here, a spoon is a utensil you eat with. I cannot reverse that and say the only utensil you eat with is a spoon, because I can give you the example of a fork. So that's not reversible, meaning that I can give you other examples that are not a spoon that fits the description you gave me. If I can give you other examples that fits the description you gave me, you weren't clear enough, all right? You have to be more clear. Concise. While being clear, you have to be concise. Definition avoids unnecessary wording while being grammatically correct. All right. Sometimes they'll do a definition if you've ever read one and it just goes on and on and on and you forgot what you were reading in the beginning. That's not a good definition. You want to be concise when you're defining something. And then the objective here is the definition avoids emotional words. When you are objective, you are not going to say something that is emotional or, like I said, opinionated. Emotional words, figures of speech, and limitations of time and space. All right. And so you want to avoid using a word that you may think fits it and then someone else's opinion may be different. And so it's very objective, meaning that you're not going to put opinionated or words that might be meaning something else to somebody else. All right. Evaluate the definition. Space is the set of all points. The set of all points. While space is hard to envision, that is the definition, the set of all points. Accurate. The defined object is named and definition is not ambiguous. Set of all points. It's understandable. We've already defined what set is in our prior chapter, our prior section. Point has not been defined. So you may not understand this definition yet because we have not talked about the word point and what that means. Reversible. The definition is reversible. The set of all points is space. That's the only definition for the set of all points. Concise. It's definitely concise. That's a short definition. Objective. There is nothing that is not objective in here. There's nothing emotional about the term, the space is the set of all points. So the only thing that might not be good about this definition is the understanding of the term point. They have not defined it yet. But other than that, it meets 4 of the 5 qualifications. So had they defined point first, then this would be a perfect definition for space. And so that's what they do. They define some just basic terms in geometry. And we're actually going to watch a video in just a second for Math Antics, which is like really young and he's kind of goofy. But I like the 3-dimensional pieces that they put in it because you can actually visualize space when he does this. Point is a dot or location with no length, no width, no thickness. It is just a location in space, okay? Point is a location in space. Line. Line is infinite. It says it's a straight set of points extending infinitely in one dimension with no width or thickness. You will hear me say that all lines are straight because straight is part of the definition of line. If it is not straight, it is not a line, okay? And so there's a phrase that says the shortest distance between 2 points is a straight line. You know, the shortest distance between 2 points is a line because by definition, lines are straight. And so that's concise. It goes on infinitely. And then they say plane, a flat surface made of points extending infinitely in 2 dimensions with no thickness. All right, so planes have no thickness. So now if we go back to space, after they've defined dot, a location in space, we actually find that space is part of that. Now let's look at the illustrations. You're going to have a ton of notation in geometry. It is important that you learn your notation, because if you give me an answer and your notation is wrong, it actually can mean something completely different because you didn't put the right notation. So let's look at the notation here. Point P, they actually can just use P if you're talking about the answer for a point. It's always a capital letter. All right, there's no anything. This is the illustration, like the picture of it, but P is just the point P, and it is defined by a capital letter. Lines are defined by 2 capital letters or a script lowercase. All right, by script I mean this little guy or cursive. It'll be italicized in your book. You can write the word line and give 2 points on the line, any 2 points on the line. Or you can write the 2 letters with this notation above it. It's a little tiny line with arrows on both ends, all right? That is your notation for line. If you do not put the arrows, it means line segment, and you will get counted wrong for that answer if I am asking for a line. So that's how important it is that you have this notation. The notation for a line is a little line with arrows on both sides. Notice that order does not matter. The line CD and the line DC are the same line, and both answers are correct because order does not matter with lines. They are infinite. So since they're going infinitely in that direction, it doesn't matter what order you gave it to me in. So if you're using 2 capital letters, you need to write the word line in front of it or do the line notation above it, all right? If you are using the script, so the little lowercase script or italicized here, then you write the word line. You do not do the line notation above the lowercase script, all right? For plane, this is what the illustration will look like. They usually do it skewed a little bit so they can try to get that 3-dimensional picture on a 2-dimensional page. And for these, you write the word plane in front of it. Plane K, if it's a lowercase script that defines it, or you need 3 letters for a plane. 1, 2, 3 capital letters for a plane. For a line, you need 2. For a point, you need 1. All right? Questions are towards the bottom. Collinear points are points that lie on the same line. It actually sounds like what it is. Collinear, all right? Points that are on the same line. Non-collinear, then, are points not on the same line. Concurrent lines are lines whose intersection is a single point. Concurrent, lines that intersect at a single point. All right. So as I said before, you're going to have definitions. So it's important that you know these definitions for 2 reasons. You will have questions like this example 2, where I say use the figure to name the following 3 collinear points. I will not define collinear for you. That is part of the question. And so you need to know the definition of collinear so that you can say, oh, 3 collinear points, that would be potentially T, V, S. 3 collinear points, 3 points that lie on the same line, 3 points that lie on the same line. 3 non-collinear points, 3 non-collinear points. Well, I could say T, W, S. While T and W are collinear, right? T, W, S are not. So 3 points that are non-collinear. And then it asks for 3 concurrent lines. Well, it just said that concurrent means they intersect at a single point. So I could say, and I would say it with my description, RT, and I would use my line notation. TV or TS, those are the same lines. And then TW. And again, order does not matter. I could have also said line K, line L, and line N. All of those would have worked, all right? So there could be multiple answers for these when you have questions like this, all right? Questions on definition. So for this first one, we have a point that is sitting on top of a plane. all right? And that's exactly what you would tell me. Point F on plane N, all right? Point F on plane N. If it is something you can use a notation for, you can write the notation as well. So try 6, 7, and 8 there. It's on page 8. You could have done the word line, QP, or you could have done the notation for it. For 7, point Q not on line L. So not on line L. Or you could have just said point Q and line L and just not, written a description that compared the two. And then number 8 was a line going through a plane. So for this one, you could have said line in intersecting. We haven't learned that term yet, but you could have said line in going through point L or through the plane F. There's a couple of things going on there that you could have described. The top of page 8, we have a lot more terms here. Coplanar. Just like collinear meant on the same line, coplanar means on the same plane. So coplanar points are points that are on the same plane. Coplanar lines are lines that are on the same plane. And then non-coplanar, non-collinear, those are the opposites there. Skew lines are lines that are not coplanar, and they don't intersect. So in order to intersect, they need to be on the same plane. So skew lines are not coplanar. And we're going to look at some examples of these. Parallel lines. Parallel lines are coplanar, and they do not intersect. So prior to this, you may have said, well, parallel lines never intersect. But that's not specific enough anymore because skew lines do not intersect either. Parallel lines are lines that are on the same plane, but they never intersect. And they give you another symbol here. This is a symbol that you need to know for parallel. It's just 2 parallel line segments up and down. And that just means is parallel to. All right, so if you were going to tell me one line is parallel to another, you would just put that symbol in between them. Parallel planes are planes that do not intersect. An example would be like the ceiling and the floor. Those are planes and they're parallel. All right, so let's look at this example for this cube. Use the cube to name the following. They want 4 coplanar points. So what you would do is you would find a plane. We could use this front surface here, plane ADEF, right? And we could actually use those points if we wanted to. Point A, point D, point H, point E. Those are 4 points that are on the same plane. They're on the same plane. You can see that point B is not on the same plane as those 4 points, all right? Not on the same plane as those 4 points. B wants 4 non-coplanar points. Non-coplanar points. So I could pick 3 that are on the same plane. We could say point A, E, and H. And then we could pick one that's not on that plane. Say point C. All right, so non-coplanar, just one of them can be not on the plane. And that means that the 4 points are not coplanar. Non-coplanar, 4 points that are not on the same plane. All right. Let's look at C. C wants 2 pairs of coplanar lines. 2 pairs of coplanar lines. All right. So we're going to pick 1 pair. We'll say that line AD is coplanar with line EH. And remember, you would want to write it AD with a line and EH with a line. So that would be 2 coplanar lines. And then they want another pair. They said 2 pairs. And so we could pick 2 more pairs that are on a different plane. We could say line CG and line DH. Those are also coplanar. They're on the same plane. All right? So this is why terminology is so important. If I ask you to give me an example of something, you need to know what it means to be able to give the example. Let's look at D. 2 pairs of parallel lines. Parallel have to be on the same plane. So this is easy. You can pick any 2 parallel lines. AB is parallel to CD, right? Parallel, they're on the same plane. They never intersect. So parallel is kind of easy. All right, parallel. What about skew? So this is the one that people kind of get confused on. For skew lines, they cannot be on the same plane. So let's start with AE. AE, and then we need a line that's not on that plane. So we could say DC. They will never intersect because they are not on the same plane. All right, skew lines are non-coplanar lines. They will never intersect just like parallel lines, but parallel lines specifically are on the same plane and they don't intersect. So skew lines are non-coplanar lines, non-coplanar lines. That's why you don't see a non-coplanar line up there, because skew line is that definition, non-coplanar lines. And then a pair of parallel planes is the last one. A pair of parallel planes. So for this one, you could use the top of this box. Plane ABC is parallel to plane EFG. All right? Those would be parallel planes. The top and bottom of that box would be parallel planes. All right? So the first thing you would know is, what does concurrent mean? They intersected at one point, right? And so concurrent at point N are lines LN and MN. You do need that notation, but the order can be flipped, okay? They just did it in alphabetical order. How many sets of collinear points can be named? How many sets of collinear points can be named? 6. Yep, 6 sets. You can just walk around. Collinear means on the same line, right? On the same line. All right? And don't forget there are lines going through there that you may not see too, by the way. Name the intersection of plane P and plane M. So if two planes intersect, what do you think you're going to get? Two lines intersect at a point. So two planes intersect, where do you think?
On a line.
At a line. So line BC. All right. So plane P, first you have to find the plane. And this is where you have to look and see, what am I looking at? I have to find the plane. All right. Plane P and plane M. All right. That's that back plane and that bottom plane there. And they intersect at this line right here. Line BC. So it's just like when my two walls come together, right? My front wall and my side wall, they intersect at that line that is my corner of the building. That's how planes intersect. They intersect at a line. So name lines that appear to be parallel to BG. All right, so you first want to find BG, and then you want to find a line that appears to be, and they say appear because you haven't been told that it is. So if I have line BG, they want a line that appears to be parallel, and so you need to remember the term parallel. And there are several that you could have written down. AF appears to be, right? That's right there. That appears to be. HE appears to be. And then CD also appears to be. All right? Questions on that?